Okay, well, we're excited about this next session as well. I'll ask the panelists to start making their way up just so we can get them up on stage. We are going to have a panel discussion. It's going to be led by Michael Coburn, and the panel title is The Next Disruptive Technology: What Comes After the Cloud and Big Data? So the panel is going to introduce themselves. Come on up and get situated, guys, and I'll introduce Michael. So Michael Coburn is a senior architect at Percona's consulting team. He's celebrating 3 years this Friday with Percona. Congratulations.
Thank you.
So Michael's a good guy. He's a hockey-loving Canadian who's moved to Costa Rica and now is taking up surfing. It's quite a life. And he's going to lead our panel discussion, so enjoy.
Great. Thank you, Jim. Good morning, everybody. Thank you for being here today. I've welcomed to the stage. We've got 6 panel participants that come from different areas of the MySQL world. And I'm going to introduce from my right, going on down the line here. So right next to me, we've got Kenneth Tui. He joins us here from EMC, where he's an OpenStack solutions manager based on their strategy of developing in the OpenStack world. He's an OpenStack ambassador and also a VMware expert, and he does a considerable amount of blogging on EMC's behalf. So you've got an opportunity where you can explain a little bit about what you do.
Sure. Can you guys hear me? OK. So I work at EMC. If you all know what EMC traditionally does, they do storage. Interestingly, in my job, I actually don't talk about storage very much. I am actually in the cloud solutions group, which means that we're focused specifically on how to help customers build clouds. And my specific areas around how to build clouds using OpenStack.
Thank you, Ken. And next to Ken, we've got Kenny Gorman, who joins us as a chief technologist from the data office of the CTO with Rackspace. He joined Rackspace in 2012 as part of their acquisition of the company Object Rocket, which he co-founded. He now spends his days hacking on projects, speaking, evangelizing, and working on the next generation of data products at Rackspace.
Yeah, hi. My name is Kenny Gorman. I spend my days mostly working to make customers successful with data projects, whether it be helping teams internally or externally listening to customer problems and making sure that our products and services match their needs. Thanks.
Thank you, Kenny. Next to him, he needs no introduction. This is Peter Zaitsev, CEO from Percona.
I'm Peter Zaitsev, CEO of Percona.
Thank you, Peter. OK. Next to Peter is Ritesh. He's a director of the Database Engineering and Operations Department within Yahoo. He's worked as a technical leader in database technology and large-scale production engineering. And in his current role, he spearheads the central database engineering and operations team and is responsible for providing database as a service for enhanced developer productivity. Thank you, Ritesh.
Thanks for the intro. At Yahoo, I take care of all the database engineering and operations team. And right now, our responsibility is to make truly database as a service so that we can have enhanced developer productivity. And if I find any spare time, I try to write some original short stories. Thanks.
Thank you, Ritesh. And next to Ritesh, another longtime guest of Percona Live, we've got Robert Hodges, who joins us as a senior staff engineer from VMware. Robert has been the former CEO of Continuant, which was acquired by VMware in 2014. And he works on the cloud data management services for VMware's cloud offering, vCloud Air.
Thank you. Yeah, so at VMware, I'm working on what we call the hybrid cloud. And that involves everything from hacking code, mostly Java programming, all the way up to planning advanced data services for cloud offerings.
Thank you, Robert. And last but not least, we've got Thomas Hazel, who joins us as the founder, CTO, and chief scientist from Deep Information Services. Thomas is an avid inventor and serial entrepreneur, and he's been at the forefront of communication, virtualization, and database science technology for the last 20 years. Thank you, Thomas.
Thank you. So the Deep team is building what we call Deep Engine, which is an adaptive database kernel information orchestration that is evolving the foundation of databases. We have a 10 meg plugin that goes underneath MySQL and Percona. And we'd love to have you guys try it out when you finish the conference this week. Thank you.
Thank you, Thomas. So thank you, everybody, for introducing yourselves. The topic of this panel is based on the next disruptive technology, what's going to come after the cloud and big data. So what we've got, we're looking forward to an engaging discussion between the 6 panelists here. And we're going to jump right into it. The first question that we're looking at, what do we think the next big thing will be?
I'll take that first. So So how many of you in the audience today think that the environments you're going to manage are going to get smaller over time? No one, right? One guy. I think the reality is that for all of us, environments are only getting larger, right? With cloud, you heard about how much data, for example, that Facebook has to deal with containers technologies taking off. What we're starting to see is resource sprawl, right? And resource sprawl means complexity. It means building distributed systems that are really hard to manage. So what I see from an infrastructure management side is that there is a need for more resource management, not just for specific applications, but for the entire data center. You start seeing some of that with some of the things that have been developed in the cloud, things like Trove to do heterogeneous database management, but you need something bigger than that. And I think you see that with things like Kubernetes and Mesos, where we need to start thinking more about how do we treat a whole data center as a single compute that we can manage and basically take the human out of managing all the sprawl.
Yeah, I kind of agree. I think that as machines generate more data, from phones to sensors to buses and cities, all these things we hear about, turns out machines are great at creating data. And I think, you saw the quadrant that Harrison put up there. Ingesting data and understanding how to take that fire hose of data and make it presentable and usable using things like column stores or compression or, you see Spark doing it these days with streaming and a couple other technologies. This is going to be where a lot of innovation needs to happen. People need answers quick, and the data is getting larger and larger.
Okay. Yeah, so I'll go back to Harrison's slides as well, but from a different side. So we have here about this very interesting saying what at Facebook they use approach focused on the application needs more than technologies. And I think for a very long time in the industry, approach has been reversed. There have been some tools often mandated, like, oh, we run Oracle, right, or something else, and then we try to essentially fit the square peg in a round hole, right? I think what has become interesting over years, last years, especially in the open source technology space, there is a lot of open source technologies and data management has appeared, and they have different properties. MySQL, MongoDB, Hadoop, they're all different, and they're open source, so essentially you can choose them relatively freely. And I would see that this transition happening of more people embracing this approach of actually choosing technology based on their needs instead of choosing technology first, and that will allow us to really achieve much more efficient data management.
Thank you, Peter.
Very interesting to see how technology is shaping our lives today. We are discussing the next big thing, and didn't we see a glimpse of it just an hour back in this very room? So, how many of you have heard of Internet of Things? Yeah, quite a handful. Yeah, so to me, that seems to be the next big thing. It looks like the ultimate social media collaboration of man and machine. If you look at human tendency, we try to connect to everything around us. And now with embedded systems and miniaturization enabled by RFID, mobility, cloud computing, and big data, Internet of Things is very much inevitable. It's actually staring at our face. You look at examples like smartphones, wearables, thermostats. I mean, all these devices, they can sense and communicate over network. So, and this is just not limited to M2M communication. We are actually looking at possibility of a globally interconnected continuum of devices and people. And now with IPv6, address space is no longer an issue. We could actually assign a unique identifier to every atom on this planet and still have enough addresses left for 100+ Earths.
Thanks. I think I'm going to go with something around data security, and there's a number of reasons for that. The first is that if you look at security technologies, particularly in the open source world. They're either very hard to use or just plain broken. The second thing is that compromising information causes really significant harm. I mean, how many people in this crowd have suffered from identity theft? So it's probably a larger number than that if you just think about the break-in at Target in 2013. That was 70 million accounts were exposed. And the third thing that's going on is there's no longer an economic barrier to entry to collecting really sensitive information. And I'll just give you a simple example. Let's suppose that we tracked everybody's cell phone position every minute and collected 10 years worth of data. Well, storage costs have gone down so far that you could store that 10 years of data for an annual cost of 3 cents. My littlest daughter could store all your 10 years of information with a month of her allowance. She only gets $3 a week. More to the point, if we were to collect that same information for 300 million people in the United States, the annual cost of maintaining that decade of data would be about $8.5 million. It's not very much. That's about the cost of building 2.5 miles of freeway in California. So you have this kind of intersection of broken technology, harm caused by the exposure, and then these technologies which are really fundamentally changing the economics of storage. I think the time is ripe for something disruptive to come out of this space.
I think the next big thing is the everlasting gobstopper. If you guys know Willy Wonka, that's probably the next big thing. But seriously, I think, you know, the silos, the big data, 90% of the world's data has been created the last 2 years. I think there's a real need for the singularity of information, collapsing those silos, reducing the data. You know, if you think about it, there's a word cat. You know, how many times have we copied that word around, you know, billions, you know, maybe even trillions of times with the YouTube video, cat video. So for me, I think the next big thing is collapsing the data and reducing those silos so that we actually can handle what is IoT's coming, all this growth that we all see coming, and you know, thank you.
Okay. Okay. Thank you, guys.
I wanted to vote for security too. I think as we all talk about these growth factors and data doubling, tripling, and security gets left behind sometimes. And I think the idea to move the ball forward and innovate has to come with the responsibility of making sure those technologies are secure. Super important point.
Thank you. Okay, so we talked a little bit about maybe identifying what the next big thing is. Why don't we spend a little bit of time talking about how are we actually going to know when it's here? When has the next big thing arrived? Are we waiting for a news report? Will one of you be telling us when it's here? Share with us.
I think we know it when we see it, but I think it's, you know, it's first it changes our perception, then it's to change the business, and then it's to change our lives. I remember when I was, I think, you know, in the early 90s, I pulled down Mosaic, and I saw this thing called HTML. When I saw that, it was not connected to anything. I was, who cares? What's this web browser, right? You know, 25 years later, it's changed everything. So I think we know it when we see it, but until it does all those three things, it's not the next big thing, ironically enough.
I think the next big thing is more of a personal thing too, right? So, you know, we talk about big data, but not everybody has big data. I think the Facebook guys were talking last year about, you know, I've got small data and I'm happy about it. You know, we all often say, well, I need Hadoop, or I need, you know, to use MapReduce on this, and you probably don't. You know, you could probably use MySQL for a lot of problems, for a lot of customers, and a lot of workloads. So I think, you know, the next big thing to you might not be what it is to everybody else. And I think that's the responsibility of, you know, developers and DBAs and CTOs and folks who are actually using the technology to figure out how much does this mean to me. Is the next big thing to someone the same thing it is to me and my projects? And does engineering going into that matter to me? And I think that's really the, you know, the next big thing is a personal thing, I guess, in my opinion.
Just coming back to security, I have a feeling we'll know that it's there because something really bad will happen. I mean, right now it's just sort of noise level. Everybody's data are being exposed, but at some point there'll be a major attack, perhaps. I mean, I don't know. Nobody can really tell the future, where the entire electrical system goes down. And then it's one of those, it's kind of like looking at Mosaic. You have one of these this changes everything moments. And at that point, you know that you're not going to go back, and that's when you know it's arrived.
So I think probably easy to say Internet of Things will be the next big thing. I won't use that. I don't know if I can predict what the next big thing is. I will predict this, though. We'll see if I'm right or wrong. That with the trend towards even large enterprises now getting involved in open source technologies, I will say in technology in the next few years, the next big thing has to be open sourced. I think we're a few years away where proprietary technology will become niche in most places.
So, Mark Weisner said something very pertinent back in 1991. He said that most of the profound technologies are those that disappear. They just weave themselves into the fabric of everyday life. I think any technology innovation, when it's no longer a niche and it becomes a part of our day-to-day lives, we know that the next big thing is here.
Well, for me, what is interesting about the big things is, I think, when it comes to really big things, not just in terms of informational technology, but in general, we as humans are pretty bad predicting them. I mean, if you would go and check some of the predictions of the 50s, we would talk about how we're going to have a vacation in the moons or how we're going to have fusion drives in the cars, right? None of those things happened, but at the same time, we have guessed now their supercomputers in our pockets, right? Well, by 15 years, which nobody has predicted. And I think if you look from this really a big scale over a significant period of time, then we don't really know what that next thing is going to be, and what we're thinking is probably way off.
Thank you, Peter. Okay, I'm hearing some common themes here. We're hearing a lot about security, hearing about the Internet of Things. I wonder if maybe we could jump to the next question, where we look at what's the criteria that's going to define when something is the next big thing.
So, I mean, comfort and convenience are obviously the things which we look at criteria. But when the technology offers something to do something greater good for society, let's take example of heart monitors, or when heart monitors can detect and prevent diseases, maybe even save lives in case of emergencies, or say environmental sensors that could detect pollution. So those are some of the criteria I look at it. And also when you see that just like new avenues for business opportunities are opening up, some of the well-established industries also become obsolete overnight. So these are some of the criteria which I'll look at.
Yeah, I'd like to add to the personal next big things. I mean, I'm not trying to promote Apple, but the Apple Watch is going to monitor you and tell you maybe if you're going to have a heart attack or your blood pressures. I mean, that's an amazing thing where, hey, don't run so fast. I think the personalization of the technology and helping you individually versus a whole would be very interesting in the next few years.
And I'm not sure, we know what it's going to be, like you were saying, Peter, about, what the next thing is going to be exactly. But we do know that it's going to be oriented around data. I think that, the one common theme, and everybody in this room is part of, is that, this is sort of a data revolution. And it seems like it just started, we were talking about 20 years ago for MySQL this morning. It just seems like yesterday that we started using databases in a fashion that is really different than we did before. And that's going to continue, in my opinion. And so, the revolution will be powered by data, and this is an exciting thing for all of us, I think.
Yeah, if I could take, I think that the criterion for knowing the next big thing is it just sort of hits some niche and completely fills it. And I'll give you a simple example. Amazon wrote a paper about DynamoDB. It came out in 2007, and it was just one of these sort of mind-blowing papers to read because, a lot of people had a lot of data, but they didn't necessarily have technologies to deal with it. And all of a sudden, this system comes along. It's horizontally scalable. It uses distributed hashing. It seems to solve the availability problems. And it's kind of this mind-opening experience where you think, hey, wow, I've got a solution to this problem that maybe I didn't even know that I had. But now that I read this paper and understand what these guys are doing, I've got to, I can now grapple with this problem and begin to solve it. So, it's again, it's that kind of aha moment that, you realize that you've got the solution in your hand.
Mm-hmm.
Yeah, actually, I like to add to that, because of the cloud, really the next big thing is from any one of you in the crowd. Now you can do it, got an idea, spin up an instance, try something, spin out more. Back in the day in telecom, we had clouds, we had big data, but now it's at your fingertips. Of any developer here, which is, I think, the next big thing is us.
Yeah, not only that, but we have more choice than we had before. 20 years ago, we had 3 or 4 databases that would fit a particular use case. And today we have, many, many more than that. So anything we want to try and do with data, not everything, but most things now have some sort of solution. And, you see folks at Facebook pushing the boundaries with different types of data stores. The RocksDB stuff is something I'm interested in and we've been building on and looking at. So I think it's great. It's a great time to do what we do because we now have a lot of choice. And before it was like, you're an Oracle guy or you're, whatever. Oh, I'm a Sybase guy. It's not that way anymore. You use everything today at your disposal, and those tools are relatively robust, open source, available, and there's a community around them. That's super cool.
Also, if you look at like 5 years before, or maybe 10 years before, people used to ask, okay, how many databases does a DBA handles? Like, what is the industry average ratio? And now with OpenStack and then people having their private cloud, I mean, you can spin off instances. So obviously that cannot be a metric, how many servers you are managing. Everybody is looking out on providing database as a service.
Okay, thank you. So let's follow up a little bit on some of these questions here. We heard a little bit from Robert where we talked about the size of data that we're collecting. We've got Thomas speaking to us about our heart rate maybe being tracked and are we going to be due for a heart attack? Are we going to correct our behavior? I guess my question is, have we captured all of the known data points that we want to get? Do we keep coming up with new data points that we're collecting? Do we know then the questions we want to ask about this data? Or are we constantly finding new ways of saying, well, we've got this data, what can we learn from it?
Yeah, I think our biggest problem today isn't we can collect all the data. I think the biggest problem is how do we turn that data into actionable information, right? I think, there's some, I don't know, so any of you heard the concept of data lakes. This idea that there's just so much data out there that there's no one, that the best thing to do is just throw it all in one place and then start making API calls with different services to try to extract useful information. I think that's the next big challenge because humans still have to figure out and program those services to figure out what is useful information versus what is junk, which is probably, and junk is probably more than 50% of the data we're collecting today.
I like to plug the relational model in Percona, MySQL. Creating relations, all that data is the key to understanding. Plug to MySQL being a big part of whatever's happening in that solution.
I tend to agree that the problem is not collecting the data. It is making use of it and understanding its value. I speak to customers a lot and go talk to them about what they're doing. And a lot of times they're storing data that they have unknown value for. And that drives their technology decisions, that drives sort of how they store it and retrieve it. And if they don't know the value, that's really hard to make a value judgment about what to do with it, how much to spend on it, what kind of team to put against it. And so understanding that value at read time and ingestion time, I think is going to be key going forward. How do I store this? Where do I store it? And what database technologies do I need to use for it?
Yeah, I agree that I think the problem right now one of the core problems in data management is analytics. And I think when we talk about big data and like what is big data, to me, maybe the most important thing is this notion that you can have vast data sets and you have ways of quickly finding out what's going on. And this was sort of the glory of Hadoop for me, and the thing that really attracted me to it was you could stick a bunch of CSV files out in a very, very large file system, and then you had things like Hive, which could attach meaning to that data after the fact, but without having to put it all in relational tables. You just attached as much metadata as you needed to know, as you needed to answer the question at hand. And I think this is a real revolution in analytics, and one that we're really far from seeing the end of it, because the technologies are, Hive, for example, is not terribly easy to use. Spark, Tez, all these other technologies are evolving very, very quickly. So So this is kind of the interesting area where I think we'll see substantial innovation over the next, probably over the next decade at least.
Yeah, so what I would think is what the main problem, in my opinion, is not our ability to store and efficiency process large amount of data. I think what we have already achieved significant progress here. Where we are lacking is ability to really ask the right questions and get the reliable answers in many industries. And I'm not sure about you, but if you follow media and let's say the scientific research in many areas, you see so much conflicting advice. Let's say like, well, full fat milk is good for you, and then it's bad for you, right? You should be eating, no fat at all, or just enough fat, or all those kind of stuff, right? I mean, if you look at that at the big data and analysis, that people would say, as if you have a tremendous amount of data and you really start to really dig into that, you will find a lot of correlations, right? And a lot of them would be noise. Another medical example for you guys, right? I was wondering myself, hey, we have this, computer tomography, right, or MRI. Why don't we just scan the people, right, and detect cancer early? Well, and the thing is, if let's say I would get scanned, right, I probably would get 10 funny-looking pieces, right, where they kind of look funny, but nobody can really tell whether that's actually a problem or not, right? So I believe our abilities to capture the data right now significantly surpass our abilities to really get a very concrete and confident answers from that data.
Yeah, so when all this big data revolution started, if you see, most of the data which was being processed was commercial in nature. And with this smart devices coming in recent years, we are getting into data which is very personal. So obviously the security becomes a very important aspect. And when all this data explosion, actually it will challenge us to build an infrastructure which is going to scale. We'll have to perhaps agree upon technology standards, develop open protocols, and establish network technologies that's going to last such massive deployments.
Okay. Well, gentlemen, we're actually at the end of our session. So I wanted to say thank you first very much for being up here on stage, and we appreciate very much your attendance here at the conference. Thank you, everybody.